Hi, everyone. Welcome to the Azure VMware Solution end-to-end networking session. My name is Amit Aneja, and I'm a product manager at Microsoft working on Azure VMware Solution. I'm responsible for the networking portion of Azure VMware Solution. So let's take a quick look at the agenda. We'll cover basics of Azure. This is a quick section. I don't want to go too deep into the Azure terminology. This is for VMware VI admins who may or may not have exposure to Azure. And then we're going to get to the meat of the presentation, which is Azure VMware Solution network connectivity as to how you connect to Azure VMware Solution from your on-premise environment. And then we'll switch to networking within an AVS software-defined data center or a private cloud. And finally, we'll talk about one of the integrations of AVS with Azure Native Services, and we'll go from there. Before we get started on the agenda of our presentation, I want to take a minute and talk about what Azure VMware Solution is. What is AVS? It's a first-party offering from Microsoft that enables you to bring your VMware workloads to Azure, native VM workloads to Azure. It's a full VMware SDDC stack that consists of ESX for compute, NSX for networking, vSAN for storage, and HCX for your workload mobility. And this is all running on top of Azure bare metal dedicated infrastructure. When you provision an SDDC or when you provision a private cloud in Azure, what you get is you get access to vSphere, you get access to vCenter, HCX, NSXT Manager. So all of this is pre-provisioned for you. Now, we do have a dedicated session on this, which is AVS Solution Overview that I'm showing in the reference section, what's new for Azure VMware Solution. So I highly recommend that you take a look at that session if you haven't already, and come back to this presentation for a networking overview. So let's get started with our agenda, which is basics of Azure. So this is Azure 101. Let's start with subscription. And a subscription is simply an agreement with Microsoft to use one or more Microsoft cloud platform or services. Simply put, you need an Azure subscription to get started with Azure. Moving on to virtual network. This is the fundamental foundational building block for your private network in Azure. Think of this as an isolated network in your on-premise world, which can be connected to other networks. You typically spin up a VNet or virtual network in a specific Azure region. You provide a subnet, which can be sliced into multiple smaller subnets. And this is where all your workloads will be running, and all your VM workloads, Azure native VM workloads will be running and deriving their network information. Moving on to Express Route. An Express Route is a private connection between Azure data center and your infrastructure in on-premise or in a colo. Here in this diagram, I'm showing one express route, but typically you will have two express route for redundancy. This would typically be done through a connectivity provider. This connection would be provided through a connectivity provider. Now, to provide this connectivity on the Azure side, we have something called as Microsoft Enterprise Edge. These are two routers in active-active HA configuration, and these routers would enable a connectivity provider to connect their circuits directly to their data center and providing you that dedicated connectivity. Moving on to virtual network gateway. A virtual network gateway is simply a gateway to your VNet. It provides you connectivity from your Azure virtual networks, Azure VNets to your on-premise. It could provide that connectivity either through VPN or ExpressRoute, depending upon the gateway that you have spun up. These are of two types, VPN or ExpressRoute gateway. Moving on to another important term, which is global reach. Now, by definition, global reach is simply stitching two express route circuits, and by definition, it would connect your two on-premise data centers, two or more on-premise data centers, through Microsoft's Azure Global Backbone Network. Now, what do I mean by that? Let me explain with the diagram. In the first diagram, I'm showing two data centers, San Francisco and London. Both of these data centers, they connect to their respective VNets in their specific region. San Francisco connects to US West Azure VNet, and London connects to UK South Azure VNet. And this connectivity is through express route. So you have two express route circuits going from your on-premise to Azure VNets. Now, traditionally, if you were to go between San Francisco and London data center, or if you were to talk between 10.0.10 subnet to 10.0.20 subnet, you would typically go through a connectivity provider, like you would have some kind of MPLS connection or some kind of inter-DC connection. Now, with Global Reach, since you already have two express route circuits going to your Azure VNets, what we are doing in the background is, and this is done via one single command, you are simply stitching the express route circuit and exchanging the routes over it. So now when you go when you enable the Global Reach, you go from San Francisco to London data center, you go on express route, go over Microsoft Azure Global Backbone Network and go to your London data center. So that's one use of Global Reach. With respect to Azure VMware solution, we are using this again. We are using the same concept, stitching two different circuits, two different express route circuits. One that's already connected from your on-premise to Azure. Another one is what we pre-provision for you when we create a SDDC in Azure, and I'm going to touch upon that in next section. Which brings me to Azure VMware Solution network connectivity. How do you connect to Azure VMware Solution from your on-premise environment or from your virtual networks? Now here I have on the top, I'm showing a customer data center, which is a full VMware stack. It could be full or partial VMware stack here. I'm showing vCenter, your typical storage could be vSAN, networking could be VDS or could be NSX. And then for the compute part, you have ESX. This data center is connected over an express route circuit to something called as Microsoft Enterprise Edges to access all the Azure native workloads. Now let's add Azure VMware Solution to the mix. Now I'm adding Azure VMware Solution to the mix, and you will see something called as Dedicated Microsoft Enterprise Edges, or DMSEE. Now, connectivity to and from AVS is provided through these dedicated Microsoft Enterprise Edges, whether you're going to your on-premise environment or you're going to your Azure VNets. Now, to provide this connectivity, we pre-provision an express route between DMSEE and MSEE, and this express route is a part of SDDC provisioning. When you create a private cloud in AVS or a SDDC in AVS, this connectivity is by default provided for you. Now, using the concept of global reach, we simply stitch the two circuits together, exchange routing information, and now you can access your on-premise workloads from AVS, or you can access AVS from your on-premise workloads just by using global reach. And again, this was just one command that you can enable, or we can enable that for you. And finally, you can use HCX on both sides to pair the two sites, to pair the two SDDCs, and migrate your workloads from on-premise to AVS or the other way around. Like I said earlier, AVS comes pre-provisioned with vCenter, ESXi, NSX Manager, and HCX Manager. So this is how your traffic flow is going to look like when you're coming from on-premise to AVS, or when you're migrating VM from AVS to on-premise environment. So we have talked about connectivity from your on-premise environment to SDDC, but what if you have workloads in Azure VNet? You're running in a hybrid environment where you have VMware native workloads in AVS, and you have workloads, Azure native workloads, or you're using native Azure services in Azure VNet. So how do you connect to that? Now, as soon as you enable global reach, the connectivity from AVS to all your VNets, which are connected on that express route, is by default enabled. So you don't really have to do any special configuration to reach your Azure VNets. This is enabled as soon as global reach is enabled. Now, this is ideal in most cases, but in some cases, this Microsoft Enterprise Edge that I'm showing here, it could be sitting a few milliseconds away from Azure DC in an Azure Edge location. So in that case, the traffic from your AVS would go to that edge location and come back to VNet. Now, if you're looking for performance, you might want to do this. You could just simply spin up a ER gateway, which is a virtual network gateway of type ER, and consume the express route circuit that we pre-provisioned for you, so that you have direct connectivity to AVS workloads now. Because these two workloads, Azure native workloads and AVS workloads, they're sitting in right next to each other in the Azure data center. Moving on to what other kind of connectivity options do we have in Azure VMware Solution? So I mentioned you connect to Azure VMware Solution from your on-premise using an express route. We also provide VPN connectivity, but this is in POC mode or 30-day trial only. HCX, which is VMware's hybrid cloud extension, the migration tool from on-premise to AVS is not supported over VPN. But again, this is supported for your trial or POC mode only. And the way we provide this connectivity is you have a VPN coming in from your on-premise to a VPN gateway in Azure VNet. And this is powered through vWAN Hub, Azure Virtual WAN Hub. And then this traffic is taken over to ER Gateway and sent over to AVS environment. Now, this kind of connectivity is not possible when you're using a traditional VNet. The transit routing from VPN gateway to ER gateway, that doesn't really work in Azure VNet. So that's why we're using Azure Virtual WAN to provide this connectivity where this transit routing is supported. Moving on to networking within an AVS software-defined data center. So we've talked about the options how to connect to AVS, Azure VMware Solution software-defined data center or a private cloud. Now we are going to look at how the networking looks like within an SDDC that you have defined in Azure, which brings me to this slide. Like I mentioned earlier, when we create AVS SDDC, we pre-provision vCenter for you, we install NSX Manager for you, we install HCX for you. Now with respect to NSX, if you've used NSX in an on-premise environment, you know that there are multiple steps to get started with NSX. First step is like you have to install NSX Manager and integrate that with vCenter so that you can talk to the workloads. You have to install NSXT software on the host. You have to install NSXT edges, which are your north-south gateway, and you have to configure them as transport nodes, which so that they can talk in terms of overlay. Now, in case of AVS, we take care of all of these steps in the background for you. So we set up NSXT managers for you. We have a virtual IP configured for them for redundancy. We integrate this with vCenter. We install the NSXT bits on the hosts. We install the edges. We configure both host and edges as transport nodes, and we protect these control plane objects. So anything that we are deploying for you in terms of NSX, we are protecting that by using principal identity so that a misconfiguration by a user doesn't really cause a service level failure. So there is clear separation of control between AVS control plane, what we did in the background, and an AVS tenant admin as to what you would do. So this is the system part of the NSXT that we are doing for you. Moving on to the logical configuration. We also plumb in some logical configuration for you so that when you create an SDDC, the SDDC is ready for consumption. All you come in, you create some segments or layer 2 switches, and you can start consuming the platform. So what do we do in the background for logical configuration? We create a tier 0 gateway, which is in active HA mode. This tier 0 is your north-south gateway to your infrastructure. If you were to go to Azure VNets or if you were to go to your on-premise environment, this tier 0 provides you that north-south connectivity. We pre-provision BGP peerings so that it can already talk to the AVS underlay, and we protect these BGP peerings and this tier 0 using principal identity. We also pre-provision a tier 1 gateway, and if you're not familiar with this multi-tiered routing of NSX, it's simply this tier 0 gateway is your north-south gateway for your workloads. Tier 1, think of this as your inter-tenant or inter-department logical gateway. So if you have multiple departments like HR, finance, marketing, you can have multiple tier 1 gateways, and you could define multiple policies depending upon that group. So we pre-provision a tier 1 for you as well, wherein you can use multiple services. We enable route redistribution, route advertisement. So as soon as you come in and you want to just simply define a segment or define, and a segment is simply just, think of this as a layer 2 broadcast domain. So as soon as you define a logical switch or a segment and you connect it to your VM workloads from your vCenter, you have end-to-end connectivity. You have east-west connectivity, you have north-south connectivity to Azure services and to your on-premise environment. We also have an option for internet access, which is enabled by default, and you can turn it off if you don't want internet access for your workloads. So this part, all of the configuration that I've talked about, this is pre-provisioned for you so that you don't really have to worry about routing, stitching, and how things work in NSXT. What can you do now? You can create overlay segments, logical switches, and connect workloads to it to provide them connectivity. You can deploy additional tier 1 gateways. You can deploy distributed services like distributed firewall for your east-west microsegmentation. You can deploy stateful services like gateway firewall, which is L4 to L7 capable for your interdepartment communication or interdepartment firewall or intertenant firewall. You can use a load balancer on tier one. You can instantiate DHCP services, which is DHCP server or DHCP relay, and you can configure DNS forwarding on tier one gateway. These are some of the things that you can do as an AVS tenant admin. Now, to simplify it even further, we understand that NSXT is a newer platform. So many of the VMware infrastructure admins may or may not have exposure to it. So to simplify the NSXT consumption for VI admins, we have a simplified NSXT experience in Azure portal, wherein you can simply define a segment. This is similar to your distributed VDS port group that you configure in your on-premise VDS environment, or a NS60 segment that you could configure in your on-premise environment. And simply here you define, this is my segment, you name it, you give a subnet to this segment, and you define a gateway. And we take care of all the plumbing in the background. In addition to this, we provide DHCP, DNS forwarding capability from the Azure portal itself. And again, we spin up, you simply define DHCP or DNS, and we take care of the stitching, like attaching it to a tier one and things like that in the background for you. And to complete the story, we also have port mirroring so that you can, for troubleshooting, you can simply come here and configure a logical span and take a look at whether the traffic is flowing through your network or not. Moving on to the next slide, which is networking in a hybrid cloud environment. So in the first section, we talked about how to connect to AVS. In the second section, we talked about the networking within an AVS. So this slide is kind of putting it all together and kind of showing you end-to-end connectivity. So on the left, I have on-premise deployment. And in this case, in on-premise deployment, I'm using NSXT. And you have your on-premise WAN infra and your tier 0, tier 1. In AVS, again, you have tier 0, tier 1, and connected to AVS underlay. Moving on to connectivity. So again, these two environments are configured and connected through ExpressRoute. So you can establish HCX, you can connect the two sites, establish hybridity, and you could use cold migration, bulk migration, or use L2 extension to extend your L2 segments from on-premise to AVS environment. Moving on to the next topology where I'm using VDS in an on-premise environment, and NSXT, again, NSXT is the default networking stack in Azure VMware solution. So, but you could have VDS on-premise, and here I'm using a web DVPG, which is a DV port group. Again, using HCX, you can create site peering, establish hybridity, and use cold migration, bulk migration, or use L2 extension. So in this case, I'm showing you a L2 extension from your on-premise to your NSXT stack in AVS. And this, as soon as you go to HCX and simply say, okay, I want to extend this network, this web DVPG to my target site, which is AVS, this segment will be pre-provisioned for you. And finally, you can just use vMotion to move your workloads from source to target. And once you're done moving all your workloads from source to destination, you can simply say unextend this segment, and all your traffic would be flowing through AVS infrastructure. Moving on to the last section, which is AVS integration with Azure services. Now, there are a ton of Azure services. I'm just going to use one of the Azure services to give you an example how you can leverage an Azure service, which is spun up in a Azure VNet. So here I have AVS environment. I have a couple of web workloads that I want to expose to internet using a load balancer. This AVS environment is connected over to Azure VNet over ER gateway. And I'm simply using Azure App Gateway, which is a HTTPS load balancer, which provides you load balancing capability. So I have a front-end public IP here on Azure App Gateway. And in the backend pool members, I'm using the VMs which are sitting in my AVS environments 10.1.1.10.20 and .30. So when the traffic comes in from internet and hits this front-end public IP address, this traffic is sprayed over to all three web VMs. So this is how you can leverage Azure native services and consume them and integrate them with your workloads which are running in AVS. Moving on to a quick summary slide. So we have talked about how do you connect to AVS. The connectivity to to AVS is through ExpressRoute. VPN is supported in POC mode only. Your on-premise networking stack, it could be VDS or it could be NSX. The next point is that the VMware NSXT is the default networking stack in AVS SDDC or private cloud, and you have full access to NSXT, which means you have full access to spin up any services in NSXT, which is DNS, DHCP, firewall, a load balancer, and you also have built-in security for your AVS workloads using native NSXT security features like distributed firewall for east-west microsegmentation, gateway firewall for your north-south firewalling or interdepartment firewall, and integration with the next-gen firewall for advanced security features. And finally, we have integration with Azure native services for your workloads in an AVS SDDC. And that's all I have for you today. Thank you for watching. I hope the session was informative. Thank you.